The green-black is from the MCM, and the white-green is from the ECM, so the engine control module. This is the one we'll be modulating here. So let's look at the behavior. What I have is I have the DC-DC converter hooked up here. You can see the output is 13 volts, and what I want to show here first is when we turn the green-black, when we pull that low, that is the MCM telling the car to turn, well, the MCM is telling the DC-DC turn off. So when the MCM tells the DC-DC to turn off, it turns off. This output supply is set to 10.7 volts. It can only source current. So what we'll do now is we'll turn the MCM is now telling the DC-DC converter to turn back on. So it turns back on to, 14 volts. Now the white-green line here is from the ECM. Now when the ECM tells the DC-DC converter to turn off, there's your 12.4 volts. So the ECM cannot turn off the DC-DC converter. The ECM can only set it to the minimum output voltage, 12.4, which is a safe voltage that won't overcharge your lead-acid battery. So it looks like the MCM is the only component that can actually disable the 12 volt. And you can actually hear the squeak. I don't know if you can pick it up. There's another thread going right now about the squeak load, and you can hear. Let me see if my mic will pick it up. I'll be very quiet. I don't know if the mic's going to pick that up. There's a clicking noise as well. It sounds like there might be a relay in the DC-DC, which I didn't know of before. I'm going to go grab my programmable load and plug it on, just because it's another issue people are talking about, and I've already got the setup. So we got the DC-DC on, and we got a programmable load hooked up. You'll notice that I no longer need this hooked up. As long as we have a load on the output here, the DC-DC is going to maintain it. Let me go ahead and turn it off, and this will kind of be a one-shot affair because it'll be off.